So for the second part of the lesson, we're going to see how transformations and parent functions are really the foundation of how we use math functions to model real-world situations. So it says when using functions to model real-world situations, first we determine what type of mathematical pattern is present in the situation. For example, the main one we focused on this year was does something grow linearly or exponentially. Once we pick a type of function, so let's say I picked linear, we can use transformations, which are sometimes represented by known formulas, such as y equals mx plus b, the linear parent function with a vertical stretch of m and a vertical shift of b. So we're going to break that down a little more. So we figure out something's linear, and we have something that's a transformation of y equals x. So the most useful transformations are to first off take the function and vertically shift it so that we have a start value. So once I know the start value for this, we can tack on a vertical shift. But that line right now has a slope of 1. Maybe I want something to grow faster or slower or something like that. So then I can tack on a vertical stretch, which is really just a slope. So we think of this, and you've done y equals mx plus b since maybe 6th grade, but that is really just a parent function with two transformations. Newton's law of cooling is a pattern about how when you take something and you put it in an environment that's either hotter or colder, how does that temperature change over time? And that is really an exponential function. So it's a transformation of an exponential parent function. In this case, we start from y equals e to the x, just like with the linear, we started with y equals x, so the base that was chosen was e, for reasons you would see in later math. We use some different variables, t for time, and big T for temperature. And if I look at my transformations, I have a horizontal stretch or compression of 1 over k. I have a reflection over the y-axis, a vertical stretch, which is in front of my function of t sub a minus t sub 0, and then, although it's at the beginning, whereas usually we would see it at the end, I can move it over there if I wanted to, and then a vertical shift. So we're not going to get into as much of how that breaks down because that's a little bit advanced for Algebra 2, but still we can see that a lot of formulas are just a parent function with transformations. So now we're going to move into using some of the formulas and specifically working on them with inequalities, which we haven't done yet. So we're going to look at each of these. There are going to be some sort of formula we've used for word problems earlier in the year, and we're going to have to use a greater than, a less than or equal to, something like that based on the words in the problem. So first one, a substance with an initial mass of 50 grams has a half-life of 10 years. Write an inequality to model the length of time it will take for less than 20 grams of the substance to remain. So I'm getting out a reference sheet just so I can have the exact variables, but this is a half-life problem. So I have, this is from my reference sheet, my pink reference sheet if you're in this class in 2026. Hopefully I'll always keep it hot pink, T over H. So the information I have, I'm starting with 50, that's my A sub 0. In my formula, T is my regular time and H is my half-life. And I want less than 20. So I want the amount or the A value to be less than 20. So I'm just using one of those formulas and writing an inequality. At any point, you can try B and C. D we're actually going to do in a separate video because we're going to get out the calculator for the last two. This one says there are 5 tests this quarter. Jeremiah scored 72, 86, 93, and 89 in the first 4 of these tests. He would like to have at least an 88 average this quarter. Right, an inequality to model the situation where x is his grade on the last test. So this problem is not the formula we have on the formula sheet. This is a basic average problem. We did this in Unit 4. And we know, just from basic knowledge, to find the average, we add up the different values. So he had 4 tests, but then he also had a 5th test that we didn't know about, and divided by 5. So that's going to be the average of the 5 tests. And this is actually more practical than an equation in this case, because you don't usually say, I just want to have an 88 average. You want to say like at least an 88 average, and that's the lowest I would want. So that means he wants his average to be greater than or equal to 88. And we're not solving any of these. I should have mentioned that. We're just modeling with inequalities. Next one, you are going on a trip where a plane ticket to the location costs $450, and the hotel you want to stay at costs $125 a night. If you have at most $1,200 to spend on the airfare and the hotel together, write an inequality to model the situation where n is the number of nights for the trip. So this is linear because I have a start value. No matter what, I have to pay for the plane ticket. So that's my B value. And I have $125 per night, so I have to multiply that by n. And that's going to model my cost. I have at most $1,200, so I could spend $1,200 or less, so that's a less than or equal to sign. So this is just an example of how we can take different problems we've done and model them with inequalities.